Welcome back to the data science modules. I have officially got my second monitor set up in Baltimore, so I am back up and running. And once again, we're going to go to Google Colab, so you can either search it in Google the way that I do, or you can type in Colab Research Google, and we're going to go here and we're going to create a new notebook. In the last video that I filmed, this is an unnecessary side note, I felt like my voice had gone up an octave. So I'm going to try and bring it back down. So I am calling this Textile. Um, this is for my summer 2023 group, and this is the power of thresholds. As always, I love to begin with text that's going to talk about our purpose. I want it to be bold because I like bold. And so our purpose here is, if I were on the right spot in my notes, to introduce trainees to the idea of a threshold and its application to immunofluorescent images of brain cells. Fun fact about me: in undergraduate, I had to write a thesis about fluorescent sensors, and I spelled fluorescent FLOU wrong the entire way through. I added it to my dictionary. It was mortifying. You can do that. My committee said just spell fluorescent right, and somehow I'm still doing well today. But now I do spell fluorescent correctly. I just wanted to put that out there. It's like one of my biggest shames. So we're gonna start this with a priming activity. One, because I think it's fun, and two, because I think it's a really great way to start thinking about thresholds in a different way, especially if it's something you've never really thought about it before. You've dealt with thresholds all your life, but to think about them mathematically is probably a little bit more abstract. So the priming activity, for those of you that are following along according to our class, we have a Google form for you to fill out. For those of you that are going to be do this asynchronously in the future, you should have a form working with you on edX, so you can fill these out in that form, but I'm going to type it out here. So you need to change a light bulb in your office, but you don't have anything to stand on. So the person to change the light bulb must be able to reach it standing on the ground. Luckily, you have a list of your lab mates' standing reach. And I put this in code and not in text. And I'm just gonna copy and paste it into text for my own sanity. So some information that you may need to know. This is a great also way to think about like engineering problems and science problems is what are some variables that you need to know in order to answer your question. So the light bulb is located 8 feet above the ground. And your lab mates and their standing reach are included in the table below. So I'm going to make a table here. This is a good like introduction to coding as well. Import pandas as PD. This is one of my favorite packages. You maybe have dealt with it if you've gone through the machine learning packages or if you did some more introduction to Python, but this is called a databasing package. The pandas name has no reference to databasing, so it's basically a way of creating spreadsheets like Excel and manipulating spreadsheets and tables. So we're going to define this data. So I'm going to say data is equal to open bracket, and then I'm going to insert some data here. So John Krasinski is 6 feet 3 inches, and his standing reach is 8 feet 3 inches. And then I'm going to put a comma, and I'm going to hit enter, still within that second outer bracket. And then I'm going to say Steve Carell, 5 feet 9 inches. My Steve is Steve Carroll, not Steve Carell. And his standing reach is 7 feet 9 inches. I'll be honest, I don't remember when I made this, if I looked up their standing reaches or if I just made those up. But I did look up all of these people's heights. All of my lab mates, I mean. 5 feet 4 inches, 7 foot 1 inch. I'm actually 5 foot 9. I guess what I could have done is just measured how high my reach is, but I don't know. Craig Robinson. Oh, I forgot to put it in quotation marks. For those of you new to coding, it needs to be in quotation marks. That way it is a string. And so I need the letters to go together rather than being a variable or a number or any other type of data. So 6 feet 2 inches and then 8 feet 3 inch reach. And then our last one, Rashida Jones, is, boop, I did it again. 5 foot 4 inches as well, but with a different reach, I think. 7 foot 4 inches. Again, I don't think their reaches are like available on the internet. I think I just made that up. Let's see if that prints out well if I made a mistake. Oh, look, it printed just fine. But it's not, the data frame that's just named data isn't, we didn't put any like labels on what they're called. I told you what each of the columns meant. So I'm going to rename this data frame LabMate Heights, and I'm going to say PD, or for pandas, see we imported as PD above. PD data frame, or data. That's that data frame I created before, which is this nice multi-dimensional list actually, rather than a data frame currently. PD data, index none. I didn't create an index column to define this by, where the column names are equal to, and this is this fancy bracket, lab member name. Put it in strings, Holly. Stop skipping strings. It's a lab member name, comma, lab member standing height, comma, open quotations, lab member standing reach. I think I called it parentheses before. I'm struggling. And then I just wanted to print my LabMate height, so I'm just going to write that down here, this open-ended print this variable statement. Columns cannot be set. What did I do? What did I do? Bear with me. I think I made a typo. Columns cannot be set. Why? Why? This is working in my... If columns is not none. It's working in my it's working in my example notebook just to the right. I'm just gonna copy paste data. Did pandas update something? Well, pandas value error columns cannot be set. It's saying that I'm getting mismatched columns. We're gonna runtime restart and run all and hope this is fixed. Otherwise, I'm gonna fix this and re-record this video. Wow, what is wrong? Okay, we can create this in a different way. I don't know what's... I have no idea what is wrong. So this is working in my example notebook in Jupyter Notebook, but we're going to try something different. So we're going to try this recommendation, which is to say labmate heights. This happens in coding. I don't know what has happened. Is going to equal pd dot data frame. And then we're going to have these columns. So we're going to open parentheses, open column, and we're going to say lab member name. And then we're gonna open parentheses, square bracket, John Krasinski, Steve Carell, Mindy Kaling, Craig Robinson, and Rashida Jones. And all of those have to be in... Wow, I really don't know why this isn't working. It's working in my example notebook. The only thing I can think is that the pandas that's running in my example notebook is a slightly older version than the ones running in Google Colab, and that there's a different way of defining the columns. Let's just check that this one worked. So when we print this out, it should say labmate heights. There we go. So then we're going to go ahead and do parentheses, not a parentheses, a comma. I've been thrown, everybody. And we're going to define this as quotation, lab member, standing height. Well, this is a good example of I'm not perfect. Code goes bad. Goes bad is like a bad description, but things can get outdated if they're not kept up, which is why maintaining a software package is so important and so difficult. And it also goes to show the way that you troubleshoot is to copy and paste the error code instance into Google, ChatGPT, I don't know, work it out, and see what comes up. It also goes to show that I try to make this come off really seamlessly for you guys with notes, and things are still happening. So 8 foot 3 inches, like that's not right. There's a crazy parentheses over here. I missed the quotation. I put that in the wrong spot. We have 8 foot 3 inches, 7 feet 9 inches, 7 feet 1 inch. You know, while I type these out, I wish I could be perfect. I'm not. Thank you all for bearing with me and my imperfections. Let's see if that prints out. Yay! Okay, so this was a lesson in something changed in pandas. This was an old way you could do it, but really what we learned is how to fix errors in typing in data frames in a different way. I typically do like to create lists first. Typically also you will import a list that's more like that, but I also import a lot of pandas data frames straight from Excel and CSV, so it doesn't really matter. This was all of our priming activity. Here we go. Since you aren't sure which office mates are around, you need multiple options of people to look for. What is the cutoff height of your lab mates to separate those who could or could not change the light bulb from a standing position? This should once again be text. So for those of you that are learning this with the summer textile program, go ahead and go to the Google form that we sent you and answer that question in the Google form. Those of you working on TEDx or any of the other platforms that we're hosting this on, go ahead and insert that answer now. Great. Pause the video, answer the questions. Great! The height you chose above is your threshold. So it is the cutoff by which you say anyone below this cannot change the light bulb from a standing position, and everyone above it should be able to. In this case, it's just a certain number. Typically, people are going to say 8 feet. You could maybe say they could reach on their tippy toes, something like that, but you're going to say it's a number. Maybe you pick John Krasinski and Craig Robinson could do it, or maybe you said Steve Carell could likely get there on his tippy toes in order to reach the light bulb. And then you're saying anything that is above that number can do this goal. All right, so let's go ahead and go into an activity. We're gonna bold it again because I want to have a party. I don't know. I don't know what that voice was. There's a thunderstorm. There's a tornado warning. I finally got my computer back. Anyhow, so that voice came out. Thresholding in images is obviously going to be a little different than picking the best office members to change a light bulb. But I do say the concept is similar. Please don't judge my grammar here. It's not the best. I should go through like with Grammarly and fix that. So let's use the same image as the last data science activities and explore the concept of thresholds. So first we're going to need our necessary imports. Now maybe I'll just document in here. Step 1, necessary imports. Switching up how I do things. That's not the best. I don't recommend switching up how you do things in science all the time because you should really write that down. But I'm feeling on a wild side. So what here I'm doing is importing a specific model from scikit image. I imported NumPy as NP. I also spelled it wrong. It's SKIMAGE. And then I'm also going to import matplotlib.pyplot as PLT. Why do I include this extra space here? This is literally just for aesthetics for me. I like to include all my like numerical packages separate from all of my plotting packages because in my more intense notebooks those lists can get pretty long and I just like to be able to see them a little bit easier. This space means nothing code wise. So because we're sticking with this, step 2 is my user inputs. So we're going to do what we've done before, which is we're going to have to go to this folder and we're going to have to upload a picture and we're going to have to upload cell.tiff. The most like insecure I feel is every time I like open my folders, like you can see my, what did I download? The paper, a webinar. I was having some issues selling some furniture, not selling some furniture. Wayfair sent me furniture that didn't have the pieces, and so I was like, this doesn't have the pieces. Here's some picture. But I always feel really vulnerable when I show you those parts of my computer. Just so that you know, every time my desktop is up, I'm like, oh, what's on there? But this isn't. I'm not a very exciting person, and this is a work computer, and there you go. That's what's on there as I was selling furniture. Back. Not selling it, I was saying, you sent me these instructions in a language I can't understand, and they're also wrong, and the holes aren't drilled. Anyhow, so our cell in location is just going to be cell.tiff. It should be in this folder, just like what we were working with back in Data Science Module 3 before I did this whole trek across the country to Baltimore. Step 3, we're going to read in the image. Also, how wonderful that I came to Baltimore and then I've been here for like 2 weeks and they're like, oh, here's a tornado warning. I should explain if you run that, it makes this one easier. I should like actually explain the code. So we've done this before where I'm defining this cell image with skimage. So I'm saying this import operations and read this cell im location. Okay. Step 4, we want to view the image because we love looking at images because we're engineers that study the brain and neuroscientists and we like to see the cells that we study. And I'm going to see plot.imshow cell im 0, colon. So that's not a 0. I said it was 0 and then it was a colon. 0, colon. CMap equals grid because it just gives it this weird color map. As PLT. Classic Holly. Some typos. The day that Holly doesn't have typos is the day I die. Um, great. Let's do colon. Mm. Mm-hmm. Okay, so here we have an image. It doesn't look very good. I also don't think. Um, anyhow, so if you want to know why it doesn't look very good, you can go ahead and you can just do this. You could just change up the numbers and be like, oh, 1, 2, 3, 4, 5. I also think this is a different cell tiff than what you all are looking at. Let me upload the correct image. Yeah, this is a cell tiff from 2020. Is it cells? Did I name it cells? Why am I losing my mind? Hi everybody, bear with me as I find this. Example data. It's cell.tiff. This isn't cell.tiff. Okay, it's in desktop. It's in packages. It's the one I uploaded for you all. It's in example data. It's in cell.tiff. Open. Do you think that just replaced it? Ha ha ha! This is the correct image. Okay, when Holly gives you the correct image, what was happening on the other one is that that was a cell.tiff from a different project, and I should stop just labeling images cells. So when you use the correct one, what was happening was there was a Z stack, and I was just going in one stack at a time. So when you say 0, you look at the image correctly. If we want to look at the image in numbers, everybody bear with me. The tornado has thrown me off. I'm off my game. We've looked at them in numbers before. You can see this array where you have a bunch of different values that correlate with either a black pixel or a white pixel. We're in this grayscale. The reason why I choose this grayscale, like, watch this. Watch this. Ugh, I just don't like those. I just don't like those colors. That's the default. See, oh, now I said Gmap. CMAP equals great. So we can see those in numbers, and why does that matter? So last time we messed around a little bit with Vmin and Vmax, but it's been a few modules since then. If you're going according to the Textile Summer 2023 schedule, if you are following along, you're like, I literally did this like an hour ago, and I'm going to just ignore you. Vmin, Vmax, it's a good one to kind of rehash. It's good for you to get more experience looking at cells and how they're impacted. So we're going to say it's the same thing. We're going to say plot im show that cell im that 0th dimension by colon, CMAP gray, this minimum value and a maximum value of 1000. How does that look? Definitely looks different. So we're saying that the minimum value that I want to show is 100 and the maximum value that I want to show is 1000, and that really reduces the dimensions that we're looking at in this image, where we see a lot more of this high saturation and less of this medium gray color. So I'm going to say in the above image, we introduced the concept of Vmin and Vmax, which are the minimum and maximum pixel values in this picture. Anything above our max gets represented as white, and anything below as pure black. Again, I typed this into code. Out of practice. Finished my PhD and I was like, I'm done with coding. I'm just gonna move across the country. Okay, so next I want you to mess around with the Vmin and Vmax until you get the values that look like the automated range that matplotlib provided in the image to above. So in this image. What values did you get for your min and max? For those of you that are working on the summer course, I'd go ahead and enter that into the Google form. For those of you in any other platform, you're either messing around by yourself or you also have a Google form, maybe. Who knows what I'm going to do in the future? So then we're going to have a recall activity. And so what I want you all to do in the recall activity is just name some similarities and differences between the light bulb example and our cell image example. Go ahead and type that in to the Google form. I just ran an empty cell, that's fun. Okay, so I taught a little bit about Vmin and Vmax in our last data management module. I recommend going back to that. Some people sent me questions. I think it's a good way to look at a different image. But now we're going to actually work on thresholding algorithms. So this time I am going to upload the OGD cells image. This time I will upload the correct image the first time. And so we're going to have now less of a priming activity and more the real deal. Why is it being like this? The real activity. Great. So we have our imports from above. We're going to need a little bit of different import. I'm just going to import it all again. That way, if I come back to this notebook, I can just start here. So from Skimage or Cyca image, I want to import IO. That's the specific image that allows me to find where an image is and import it into my notebook. And I'm also going to, from filters, import try all thresholds. And then once again, I don't need to do this. Like you're probably like, oh, you imported these earlier. This is for me. This is if I come back to this module, I can just start at the real activity, hit this import, and be done. It is redundancy otherwise. Okay, step 2, we're going to do user inputs. This time we're going to see our OGD cell im location is just going to be equal to open parentheses, open quotation marks, OGD cells.tiff. Great. And then we're going to read it in. You know, you guys are used to this. Just a caveat here that I like to add in. I'll just copy and paste it because you don't need to type this in. This is a cell image that's from our actual publication. You can look it up. I had the people on Textile Summer 2023 read the paper, so hopefully some of you actually read the paper if you're with the Textile program. But I just wanted to provide this information. If you want the actual publication, you can look it up. It's in Bioengineering and Translational Medicine. I think it was published in 2020. Maybe 2021, I don't remember. So this time we're going to say our cell im is equal to io.imread OGD cell im location. I don't have the shortest variable names. We'll just deal with that. Okay, step 4, we're going to split our color channels. We've done this before. So I'm going to go ahead and say red cell im is equal to cell im. Keeping in mind that this image is formatted differently than cells TIFF above, so our colors are the last channel. Green cell im is equal to cell im. Hopefully now that you all have learned with food about the wet lab process, you can see how we can control how these images are saved, and it's not always standard. Sometimes they're saved in different ways just based on how we worked with the confocal. Step 5, we're going to try some thresholds. So this should be pretty fun, and I'm hoping the rest of my module follows my example. So we're going to say fig ax trial threshold. So trial threshold is this function that we imported from this module, filters inside of Skimage, and we're going to do it on the green cell im because those are our microglia. I'm going to define a figure size that works well for my laptop. I'm going to say verbose false. That just tells you a lot of information and it annoys me. And then plot show. I didn't put an equal sign here. Equal sign. It takes a minute. It should take a minute. Also, I'm trying to upload a YouTube video, trying to download a software, and there's a storm outside, so my Wi-Fi is a little bit slow. But this shouldn't be Wi-Fi. This should just, oh no, it is processing. Here we go. Cool. Now you guys have actually thresholded. This is so exciting. So this is the original image. Why does it look so weird? So when we were imaging our cells here, the amount of signal that we got in comparison to our background is kind of small. And so in order to actually see the cells, you have to change what are the LUTs, or the intensity values you can see. That's something we do with Vmin and Vmax, but this is our original data. You can see that there are cells there, and I promise you the cells exist. This is our thresholding. These are algorithms that exist. They're really common algorithms for thresholding. I think Otsu I'm so sorry, everybody. I also have allergies. Is the most common thresholding algorithm. I've used Otsu and Lee. They tend to do well for me. And these are all of our cells. You can see how the amount of a cell that shows up changes based off of the algorithm. You can look up all of these algorithms if you want to, and their differences on Wikipedia or in Scikit Image Trial Thresholds. And then you can see that the minimum threshold didn't run. It hit a runtime error. Okay. Step 6, I want to visualize the original image. So I'm going to just say plot im show cell underscore im. I'm sorry for sneezing. It's taking a minute. Warning, RGB. So here we can see once again we have these green microglia. We have this red PI. This is an injured cell image. This is after oxygen glucose deprivation, so our cells have been deprived of what they eat. And then this red is that PI stain over DAPI, which is our nucleus stain. And so now we have a question. So based on your eye alone, which thresholding method seems like the best method for thresholding the green channel? And once again, if you're with us on Google Forms, then go ahead and use Google Forms. If you're with us in class in another avenue, go ahead and insert your answer there. Cool. I'm going to actually enter text this time. So our activity, we are now going to specifically apply just one threshold, the Otsu threshold, adding the import statement below since it is relevant to this section. So I told you a few modules ago, typically I like all my imports to be together. But in this case, when we're teaching, I'm putting them differently because it makes sense narratively. Threshold, Otsu. So we're going to go ahead and do the Otsu threshold. It tends to be a pretty standard threshold to use. It tends to work well on cells. It's very common to use with ImageJ, which is the most common like processing package for biological images, especially Fiji. So we're going to say thresh. So I'm going to say this is the threshold is going to equal threshold underscore Otsu. So it's that function from Scikit Image Filters that we just imported. And I want to apply it on my green cell im because I don't really care about the DAPI stain or the PI stain. I have done this process on DAPI if you want to on the nuclei. I can talk about the benefits and the difficulties with that. And here we're going to say for our binary images anywhere where the green cell image is greater than the threshold. So if I just type thresh here, we get this number 191. So this is the threshold cutoff that has been determined for this image. So describe in the Google form in your own words what this actual value above means and how it is represented in the 3 plots below. I cannot add a text. Where is my mouse box to save my life? Every time I add code, I know you can just change them over. Again, just bear with me. So we're going to make the 3 plots below. So we're going to say these figures have these axes, and these figures are plot dot subplots, N columns equals 3, fig size. This just works for my computer. Change it for whatever works for your screen. Where the ax is axes.ravel, and ax0 is going to equal plot dot subplot 1, 3, 1, ax1 plot plt dot subplot 1, 3, 2, and ax2 is equal to plt dot subplot 1, 3, 3, and I want it to share ax with ax0 and share y. It should be share x, not share x, with ax0. Okay, and now we're going to define this ax0. So the first plot is going to be im show that green cell im cmap equals plt cm dot gray. Ax1 is going to equal ax0 set. It also isn't equal. Ax0 dot, sorry everybody, set underscore title original. Ax0 period axes off. Ax1 period hist green cell m ravel, and we're going to define the bins equals 256, and ax1 set title histogram. You can use 2, but I like to keep it 1. I'm going to capitalize this just to be difficult with myself. And then ax1 axv line thresh color equal. I said earlier I was going to keep my voice out of whatever high octave I made my last video in, and then I wasn't. So here we go. Ax2 im show binary cmap equals plt cm dot gray. Ax2 set title thresholded. There's not like a good way to just use threshold as a verb, so I just have fun with it. Axis off. And then I'm going to say plt show because sometimes it doesn't show it. This will just show it in line. Ah! What did I do? Figsy. What is that? You guys should have told me I had typos, so I bet this is just riddled with typos. I could just copy and paste. If I copied and pasted though, then it wouldn't be as like fun. You guys wouldn't get to see me struggle. Okay, here we go. We did it. Okay, so these are the 3 images below. So go ahead now and answer, describe in your own words what that actual value above means and how it's represented. Do that for a hot second. A hot second is like more than a few seconds, you know, it's as long as you need it to be, but it's not always quite a minute. My father asked me what that meant the other day. Okay, so we have the original image again. So this time it's a histogram of what all the pixel values of our cells show up as. So you can see this huge peak. In immunofluorescent imaging, typically that huge peak is just our background. Most of our image is black. We want it to be that way. We don't want a lot of out of focus imaging, and we want to have these nice sharp peaks for our image. This red bar represents that 191 threshold of our image, and our thresholded image is now what it looks like once we've applied that. Okay, that was pretty fun. So now we want to look at what the green cell M, or the original image above, and the binary M, the thresholded image above, look like to the computer. So if we just type in green underscore cell underscore M, we can see it's this array of numbers. And if we type in the binary, we can see it's an array of booleans. So booleans are true or false rather than numbers. Are you surprised? Surprised by these results? Go ahead and insert that into the objects, results not found. Do this literally every single, I need to stop saying literally in all of my sentences every time. Go ahead and answer that into the Google chat. Pause the video. Okay, so when we thresholded, back here we actually made a Boolean statement. So we said use this algorithm to find the cutoff that we should have for our image. And then we said make this binary for me, or a yes or a no, or a 0 or a 1, where any time where the green cell im is greater than the threshold, we have a true, and any time it's less than that, we have a false. So this image actually only has two values, either white or it's black. We lose that dimension, we gain information about our cells. We'll be able to use that on Wednesday to actually quantify cell characteristics. So I have just one last thing I want you all to do here. And so I want you all to do a recall activity. So I think it can be quite fun to look into the mathematics of what is happening. So glance through the Wikipedia page on Otsu thresholds. So Wikipedia onto threshold. And go ahead and read through this page and just add something into the Google form below. That is, what is one cool or not below? I'll include the link. Surprising thing you learned from that page. And thank you all for learning to threshold with me. This is a huge step to being able to quantify cell images. We've really come a long way this summer. And thank you for bearing with whatever issues happen there. Signing off. I don't know. And goodbye.